Hello, everyone. I'm Janine Donnelly, Manager of Webinars for Tech Channel, and I'd like to welcome you to our presentation. We will be holding a Q&A session at the end of the webinar. You may ask a question at any time during the event by entering it into the Q&A panel. If you experience technical difficulties during the webinar, please use the Q&A panel to alert us, and someone will assist you. You may download a PDF version of the slide deck by clicking on the drop-down menu labeled Event Resources. You'll find that on the left side of your screen. And know that you can download those right from the platform without being disconnected from the webinar. Today's webinar, Affordable Cyber Threat Protection and Business Continuity with Mainframe Virtual Tape, is sponsored by Optica Technologies. Our featured speakers today are Sean Seitz and Serge Rial. Sean is VP of Technical Services at Optica and is responsible for technical sales, services delivery, and market support worldwide. His 30-plus years of mainframe experience includes business management and executive positions in technical sales and support, product management, business development, and consulting services. Serge is a senior technical services engineer and has an extensive background in tape and disk storage solution design and architecture, including a breadth of experience in systems engineering, systems integration, and quality assurance. Serge has more than 28 years of experience in key roles within the storage networking industry, including the last 25 years focused solely on mainframe-related storage and security. And with our introductions complete, Sean, I'll turn the presentation over to you.
Thank you, Janine. Really appreciate it. And I wanted to make sure that I thank you and Hannah for your professional support. We've grown to really appreciate that and working with Tech Channel over the years. So thank you very much. I'd also like to thank everybody who's taken the time to attend today, whether it's live or on demand. We appreciate that you've done that out of your busy schedule. So I'd like to just give you an agenda here first so you have an understanding of what to expect and what we're going to cover today. So I'm going to first start by giving you an introduction quickly to our product family. We have several models in the ZVT virtual tape family, and it's a good foundation to understand those models and the distinctions between them as it relates to cyber protection feature set and solutions. So I'll give you a quick intro to the product family, and then we're going to get into the actual solutions, the features and solutions. I'm going to have my partner, Serge Rial, cover the advanced feature set. There's going to be 4 features that we highlight today that are related under what we call our Cyber Shield set of features for ZVT. So Serge is actually going to take that section in the middle here and cover those in a little bit of detail, each of those 4. And then I'm going to take back over and we're going to talk about the various combinations that you can use of those features to implement solutions to help you with cyber protection and ransomware protection on the ZVT. We're going to also show you several customer examples, actual deployments that have leveraged these features for cyber protection. And then we're going to wrap it up with a quick summary of the benefits and then conclude with questions. So we will, as Janine said, have time at the end for questions. So we look forward to answering any questions that you have. If we don't answer them live today in the session, we will certainly get back to you by email or telephone to answer your questions. Okay, so there are 3 models within the family, as I mentioned, and you can see them across the top here. The 5000 INAS, the 3000i, and the 5000 Flex. These 3 models are all based on the same exact technology. They're based on the same platform and what we call the virtual tape node. You'll hear us refer to the virtual tape node, or in short, the VTN. The VTN is the engine. It is the virtual tape engine that attaches to the mainframe via FICON, and it virtualizes the volume and moves that to storage. And each of these 3 models has a little different manner in which it leverages the storage that is the repository of the virtual volumes. But it is a unique technology. The GUI is identical. The virtual tape node is identical technology across the family. Okay, that virtual tape node comes standard with 2 FICOM ports that are 32 gig capable. So you have built-in investment protection, and that those FICOM ports are already 32 gig capable. As soon as IBM delivers 32 gig FICOM on the mainframe, you're going to be able to plug and play with a ZVT. Optionally, you can upgrade to 4 ports on a single virtual tape node. So 4 32 gig FICOMs is an option per virtual tape node. Okay. All of these models use the same exact web-based GUI. Anything you can do in our extensive GUI, you can also do by CLI and JCL. So you have full flexibility on how you manage and monitor the systems. You have probably the most flexible suite of replication options in the industry with the ZVT. There's 4 different modes that we're going to talk about quickly that you can choose from depending on your requirements. We offer a feature called one-click DR, which is one of the advanced features that our customers tend to really appreciate. That is the ability to, with a couple of GUI clicks, actually with one single GUI click, I should say, your DR ZVT is prepared for your DR testing. And so you're ready to begin testing. Your production replication continues uninterrupted. And so with a single click, it's a very efficient way to prepare for your DR test. All right. We take great pride in our service and support, and that's one of the things that we like to think is a distinguishing factor. When you choose Optica and you choose ZVT, you're going to get world-class service and support along with the product and the solution. Okay. And then I'm going to tell you a little bit about some efficient migration tools that we have, including a hostless option, which is industry unique. So now let's talk about each of the 3 models. Starting on the left, the 5000 INAS. This is what I would consider our flagship solution. It's the most scalable, the most modular, the most resilient solution in the industry. When I say modular, scalable, and resilient and flexible, you can build and architect this INAS solution to meet your performance requirements, your capacity requirements, and your data resiliency requirements. All 3 of those things are customized based on your requirements and can be built to match what you need. This system scales to multi-petabyte. It's 11 petabytes within a single INAS system, so massively scalable. You can, of course, design it with highly available features and make the whole system highly available, in that you can lose virtual tape nodes without interruption. You can lose complete storage nodes without interruption to your tape operation. So you can architect this in a manner that makes it very highly available. You can have up to 8 VTNs in a single system, between 1 and 8. You can also get up to 2048 virtual tape drives configured on the single system. So it's 256 virtual tape drives per VTN, so that gets you to the 2048 if you have a fully populated 8-node system. Likewise, performance is measured essentially at about 1,000 megabytes a second per virtual tape node. So if you require 2,000 megabytes a second of performance for your virtual tape system, we recommend 2 virtual tape nodes in your INAS system. Now, along with that performance, 2 virtual tape nodes is going to give you that redundancy as well. The tape database is shared in that cluster of 2 virtual tape nodes. It's always synchronized between them. If you were ever to have a catastrophic failure of a virtual tape node, the database resides on the other one and automatically will take over the virtual tape system as the kind of the controller engine of that system. So those are ways that we scale performance. We can scale resiliency at the virtual tape node layer. And then at the storage layer, you can add nodes easily and dynamically to grow capacity. And this system is also based on, the storage is also based on erasure coding technology. So a highly advanced resiliency technology that will allow you, depending on your setting, there's layers, or I should say levels of setting on the resiliency. You can go between 1 and 6, 6 being the most resilient. The more resiliency you have, the more reserve capacity you have. And so we take that into consideration when deciding on the resiliency level to set for you. But you can lose, for example, the default is level 3. At level 3, you can lose up to 3 disk drives in every single storage node at the same exact time with no impact to your data, for example. And you can also architect it such that you could lose an entire storage node with no impact to your data. So there's lots of choices and resiliency options that we build into the INAS system. Compression is a standard feature. So compression, hardware compression comes standard in all 3 models. Deduplication is a standard feature of the INAS. Okay, so that's a critical component when you talk about ransomware solutions because of some of the features we're going to tell you about. Deduplication is a critical feature that gives you a very high efficiency of your capacity. Okay, and then finally, WAN optimized replication is a mode of replication that our customers often select. And the reason is it goes between the intelligent storage nodes of the INAS system. So only deduplicated, changed data is passed across the wire for replication. So it's a highly efficient replication method, and it applies really nicely for customers that have limited bandwidth on the replication link, for example, because a very limited amount of data is actually sent across the wire due to the deduplication feature. All right, let's move to the center here, the 3000i. This is the entry-level solution. It is what we call the all-in-one solution. The storage is actually on board the 2U VTN. So you see the 2U VTN here pictured at the bottom. The storage is on board, and you can have 8, 16, or 24 terabytes of usable capacity. After you apply compression to that usable capacity, you get 32, 64, or 96 terabytes of effective capacity. So once your data is parked on the 3000i, it's compressed, you have 96 terabytes maximum of effective capacity available on the 3000i. Okay, but it comes in 3 different sizes, capacity levels, to meet your requirement and therefore your price point as well. Okay, this comes standard with 16 virtual tape drives, the 3000i does. You can add virtual tape drives by license up to 256 on a single node. And then you have that same 1,000 megabytes a second on average per virtual tape node on the 3000i. Okay? And then finally on the right, the 5000 Flex. This is somewhat industry unique in that you can attach any fiber channel or NFS attached storage, any third-party storage, behind our virtual tape nodes to make up your virtual tape system. So you can see some brand examples in the cloud there on the right. And we attach to all of these in the field in various customers today. Some advantages of the Flex system would be, let's say you have a strategic investment or relationship with a particular vendor of storage and you use that storage predominantly for your distributed side of your house. You have extra capacity available. You buy very attractively of a certain brand. You can absolutely use that for your virtual tape, your mainframe virtual tape application. You can either dedicate that backend storage or you can share it, carve out some capacity of your existing environment for your mainframe virtual tape application. Oftentimes, a customer already has established replication infrastructure for their distributed environment between, let's say, IBM flash storage, for example, just to pick one. They already have that replication infrastructure established. It's very simple to carve out some extra capacity for your mainframe virtual tape application. You already have the replication infrastructure in place. Off you go. So there are some real advantages to the Flex model for particular customers. It's not for everybody, but if you have some of those things that we've talked about here in place, then it could make sense to consider the 5000 Flex. Okay, so that gives you kind of a baseline on the family. We have an extensive list of enhanced, what we call enhanced features. We're here to talk about that upper left category, right, the security category for ransomware protection. So I'm going to skip past that and let Serge get into some more detail on each of those 4 features there. But in terms of replication and cloud support, I've already referenced probably the most extensive repertoire of replication options. We have two different specific types of replication, and then within those two types, we have multiple modes available. So that includes synchronous options, asynchronous options. We have what I mentioned is the WAN optimized, which goes between the storage nodes to give you, that replicates only the changed and deduplicated data. So we also have a what we call virtual tape node replication type. That goes between virtual tape nodes. The main advantage to VTN replication is the ability to manage and monitor the replication sessions very granularly from the GUI, from the web-based GUI. So that tends to be the main advantage of VTN replication, customers that appreciate that monitoring capability in the GUI. Cloud support, that's the one that's listed in a couple different categories here, but we support cloud. We support writing tape to the cloud in multiple ways, and Serge is going to touch a little bit more on that in a little while. We also support third-party storage replication. That would be for the Flex model I referenced before. So if you choose Infinidat storage, you choose Hewlett-Packard storage, you choose Dell storage, you can take advantage of the replication functionality of your storage with the Flex system and for your mainframe virtual tape application. In terms of data migration, right? This is the very first thing the customer wants to know when we're talking to new prospects. How are you going to move me from where I have today, my legacy tape environment, to the ZVT? How are you going to do that safely and efficiently? We have a tool set that we call ZCC, ZVT Control Center, ZCC for short, that has a very powerful migration engine in it. It works with any ZOS environment. It's installed in the mainframe. There's a couple really interesting and neat things about ZCC migration. This tool set will allow us to actually have the legacy tape system online to the mainframe as well as the ZVT online to the mainframe. And we can start a migration of your volumes while you're doing live tape operations. ZCC will serve as the traffic cop. It knows where to direct that tape mount. If the tape has not been migrated yet, it directs the mount to the legacy tape system. If that tape has been migrated, it will direct the mount to the ZVT. So you have the ability to stop and start the migration in ZCC. It picks up right where it left off. So it's a very efficient tool that we use to migrate customers in ZOS environments from their legacy system to the ZVT. I want to mention one other thing, and that's hostless migration. This is absolutely industry unique. No other vendor offers this. We have the ability to change the personality on our FICON ports on the ZVT to emulate a mainframe FICON channel. So with a couple clicks in the GUI, you can change a FICON port on the virtual tape node to migration mode. It becomes a mainframe channel that connects to the legacy tape system directly, so a FICON link from the ZVT port to the legacy tape system. Doesn't matter what that legacy tape system is. It can be physical tape, any brand of virtual tape, and we will import those tapes and migrate those tapes directly over that link. The data will not flow through the mainframe, and therefore you're not using mainframe cycles to migrate the data. So this is a really interesting feature that no one else offers. And we will consult with you when we sell a system. We consult with the customer to determine what's the best way to migrate you from A to B, to get you to ZVT the most efficient and appropriate manner. Hostless may fit your application, and if so, it's a very, very good way to migrate to the ZVT. Finally, there's a category called operations features. We can automate scratch processing. So as soon as the tape management system scratches or retains the tape, it's scratched or retained exactly at the same time in the ZVT. So it's real-time scratch processing that you can implement with ZVT. We have the GUI interface that's extensive, intuitive, as I mentioned. Anything you can do in the GUI, you can also do by CLI. We offer the one-click DR that I mentioned before on all models, and we also offer multi-tenant support. So the ability to logically isolate specific customers' data within a system, within the INAS system, right? So you have a logical separation of not only the data, but the tape drives, the libraries, et cetera. Okay, so that's just a high level. So let's talk a little bit, let's get into what we call the Cyber Shield set of features that we came here to talk about. Before we do that, a couple statistics. I think this is always kind of interesting. We all are familiar with ransomware, what it means, right? It's a malicious attack that encrypts your data, and you do not know that it's encrypted. And so the attacker will wait a period of time. They'll come to you and ask for a ransom or a payment for access to your own data, right? So this is becoming a massive business. Back in the day, this type of hacking happened for sport or spite. Guess what? It's huge business with the entree of Bitcoin and electronic currency. It can be done completely anonymously, and therefore it's become a massive business, unfortunately, for all of us. So it's on top of mind for everybody in IT these days, of course. So I wanted to refer you to a few interesting statistics that I pulled from the IDC ransomware study last year. Hard to believe, but 37% of global organizations were victims of or some form of ransomware attack. That's a big number. Of those organizations that were victimized, only 13% of them avoided actually paying any money. So that means that 87% of them were really not prepared and had to pay ransom to get their own data back. And there's no guarantee, even if you pay, you're going to get your data back. The average ransom that was paid in 2021 was $250,000. 93% of the successful ransomware attacks, the attacker breached the network, right? So that's probably not a big surprise, but breach of the network is by far the biggest way that ransomware attacks occur. The most common cause of the network breach is 4 items. Compromised credentials is by far the first and top item. Human error, misconfiguration, or bad maintenance, poor tardy maintenance rounds those out. But compromised or weak credentials is by far the biggest reason that hackers were able to penetrate the network. Ransom attacks, of course, have predominantly been affecting distributed systems, right? We love the fact as mainframers that we work on the most secure platform in the globe. However, there are well-documented successful attacks on the mainframe. And guess what? Those aren't slowing down. They're only picking up because of how lucrative it is to actually successfully hack a mainframe, with more than 70% of the world's data on mainframes and more than 90% of all credit card transactions being processed on mainframes. You can see how lucrative it is in this ransomware world we're living in. So those are some interesting statistics I wanted to share. Okay, so let's get into the feature set, the CyberShield feature set that we came here to discuss. So at a high level, these are the 4, and then I'm going to turn it over to Serge after just giving you a quick thumbnail on each of the 4. I'm going to turn it over to Serge to get into a little bit more detail for you. The first is what we call enhanced data integrity checking. This is a standard feature on all models of ZVT. We encourage our customers to use this 100% of the time. Doesn't matter what model you have, doesn't matter if you're thinking about ransomware. This is a no-brainer feature that gives you the peace of mind that your tape data is always accessible, always readable. So what this does is it checks in the background, depending on the mode that you set up, checks in the background that your tape data is 100% valid, not corrupted, not modified, and you can read it back when you need it. So this is a feature that is standard and we encourage all of our customers to use. Second feature is what we call ISN cloning, Intelligent Storage Node Cloning. This is a feature exclusive to our 5000 INAS. This is also standard on the INAS system. And this gives you the ability to take a snapshot, a clone, whatever your terminology is, it's all the same, right? They're all the same general meaning. You can take a clone of your file system and maintain that a directory of your clones so that you can reach back into your directory and restore your data from the first clean copy. So as a standard feature, you could implement cloning on your production ZVT system for no additional cost. You could do that on your production ZVT if you so choose. So you have a built-in ransomware feature here that we're going to tell you a little bit more about, okay? Third is worm. We all know what worm is. right? Once read many. This feature's been around with physical tape going back decades. So you have the ability on the 5000 INAS to license the worm feature as an added protection for ransomware. Okay, we all know what this does. You basically have the ability, based on your configured expiration date, to identify a set of tapes that cannot be overwritten, cannot be modified, cannot be erased for that period of time until the expiration date passes. So that's a feature that we offer in the suite that we'll tell you a little bit more about next. Finally, cloud support. This is something that everybody's thinking about. Not everybody's implemented yet. All models of ZVT can write tapes to the cloud. And so there's an advantage when you're thinking about cyber protection, ransomware protection. If you're storing volumes in the cloud, you have the ability to restore from any location that you have as ZVT. So the main benefit of cloud is being able to restore from any location. So with that, I'm going to step aside. I'm going to turn it over to Serge, and he's going to give you a little bit more detail on each of those features that we just highlighted there. Serge?
Thank you, Sean. So we will go through each one of those 4 features as Sean briefly described here in a bit more detail. So let's start with the integrity check. Basically, the way we deal with that is we use the CRC sent by the payload, with the payload on the FICON channel. So as the data is written from the mainframe, each block has a CRC that's calculated by the mainframe. We write the data to the AWS file, and the CRC is actually written to a separate file. Right? So, and that's carried end to end. So when people say, how do you guarantee integrity? We basically take the CRC from the mainframe and store it with the data in a separate file. And that allows us to basically be able to later on read the block, read the CRC, and make sure that it is all good. The CRC is actually written to what's called an offset file. Now, if we go into a bit more detail on the ways we can do that, it allows customers to guarantee the integrity of their data. As I just mentioned, we store both CRC from the mainframe and the data in separate files. So the data can be validated immediately upon being written in one of the modes, or daily, depending on how you want to set it up in your environment. Right? But that is done through the life cycle of the data. Right? It's basically designed to provide peace of mind for the mainframe customers, to ensure that you know your data is always there and valid. Sometimes, you might take 20 backups and you don't need to deal with them for 5 years, but a year down the road, something gets corrupted. If you knew then, you'd probably be able to react faster, or maybe able to regenerate the data. So that's basically one of the things it allows you to do, is guarantee that data integrity for the life of your data. If the integrity check fails, you get, if you have alerts configured, you can get an email or an SNMP, and it's also posted on the GUI as well. So if you look at your user interface, you'd see there's a red message on the right side that would say, hey, we have issues here, that you can drill down and go look at exactly what the issue is. We have 3 modes for integrity check. The first one is what we call library-based, a nightly check. So each one, when you create tapes, we create what we call policies. So it's a range of tapes, it's a policy, and the policy goes into a library. You can look at it from your old tape library, drawers and drawers of tapes or whatever. So those are the libraries. So you can have that set up to do an integrity check nightly basis. So that will, if you have integrity check configured every night, there's a task that starts at a given time, and it will start to read back every tape in that library and compare the CRC with the original CRC with the data. If it sees an error, you'll get a notification. That's done in the background. If it takes more than any people sometimes ask, well, if I have, 1 million tapes, it won't get done in 24 hours. No, it won't. But we will try to reschedule at the same time every night. If the task is still running, we don't reschedule. We just wait for the first one to be done. The next approach is a Valsir-based read after write. So that's more to verify that your data has been written in on your storage correctly. This one basically, we will write, when you write your volume, when the volume gets unloaded, we will start a background task to do the integrity check. So you will not know immediately, but you will know soon after you write your tape if the tape data is good on your storage. Again, that could be our storage, that could be a third-party storage if you have a flex system. And that's to basically guarantee that the tape was written properly. Now, if you want to be 100% sure right away, the third mode is read after write synchronous. What that will do is when the tape is written and we get the unload command, we will not unload the tape right away. We wait. We do the entire check at that time, and will only give you the device end for the unload when we verified that the tape is actually completely written without errors. So that's basically would extend your job time because now the job is pending the unload until we've done the verification, right? These modes are more basically to ensure the data is written properly on the storage right away. The library-based is more the one you would look at or look for like a ransomware or cyber attack type of situation. If somebody comes from the outside and tries to modify the data, we will catch it because the data would no longer match the CRC. And as soon as we get to that tape, we'd say, hey, there's errors, there's errors, there's errors. We need to look at those. So that's kind of an early warning detection for that type of cyber attacks. The next feature is for the INAS system, we have what we call file system cloning. Again, this will go into a bit more details on that. File system cloning basically allows you to, from the INAS, you have one or many file systems mounted, exported, so you can actually see them from the VTN. And your data, your day-to-day tape data is written to those. What the cloning process is basically it takes a point-in-time snapshot of the actual storage. And that, because of the way the system works with erasure coding and deduplication and everything else, it's basically just a set of pointers to the actual data, right? So that's done really fast. So we basically take a point-in-time image of your data and put that away. And basically, the cloning creation and management process is all done through automation. So we provide scripts to allow you to capture how often you want those clones, on which file system you want them, and things of that nature. All right, so for ransomware migration, when you clone a file system, the file system is not mounted, so or not even exported, so it's not visible to the outside world. It only is visible within that storage, within the intelligent storage node. So it's not visible to anyone. And again, because it's on the file system basis, you could have, test data on a file system, your production data or critical data on different file systems that you want to clone potentially more often than your test data, or you don't even clone your test data at all if you don't want it. But that allows you to select which file systems, which tapes you actually want to keep images or snapshots of, right? So basically the cloning hides the data. Those clones are not exported and therefore not visible. Even if somebody was on the VTN and said, hey, show me all your file systems, they would not show up because they're not exported to the outside world. Right. So the next feature is the INAS one. Again, that's an INAS feature. This one is a license feature. It's the WORM, as you would all know, write once, read many. And that basically, we'll quickly go through the features and then a quick example. So as I said, it's a license feature on the INAS. It protects the data written to the INAS file system. It's an immutable copy. So as soon as you close the tape, that tape is no longer writable. You cannot write it, you cannot update it, you cannot delete it, you cannot do anything with it. So that is a feature that's enabled at file system creation. So when you have to plan ahead, if you say I want to keep a gold copy of my data, I don't know, you do a backup once a week and you want to make sure that that never, or that is safeguarded for a certain period of time, you could write that to a worm. So that needs to be planned ahead and enabled on the file system. It cannot be enabled once the file system is created. There are two configuration modes for the worm. There's a compliance and enterprise mode. The compliance mode basically will not allow you to modify anything until the last file has expired on the worm file system. So when you create your file system, you set an expiry or a retention period, and until the last volume or tape on that file system is expired, you cannot do anything with it. The enterprise mode, however, gives you the flexibility with privileged admin to delete the file system if you need to. It protects it. It allows you to basically change the retention date and delete it if you need to delete it ahead of what you had, or you decided that you were going to do a 90-day retention, but that's too far out and you want to change that. It allows you to potentially back the date, but only to a certain point, and then delete that file system. But again, you can never modify it. So nobody could come in and say, well, I'm going to change the retention and then start changing files. You cannot do that. The system will not allow you to change a single file on there. The only option you have for a warm file system is to delete it when the retention period ended, which means at that point you no longer need the data. So the warm features, again, as I said, configured by file system. The retention period is set by file system. And again, data that's more important, more critical, but more cyclic, I would say. You don't have to retain it for too long, so you can set a file system for that. If you have archived data that you need to protect forever, you can make a very long retention. That data is never going to go away. Volumes can be mounted, the file system can be mounted read-only, but it cannot be mounted and written to, scratch, or deleted. The only way to get to this data would be to clone the worm file system, which means you don't affect your clone file system itself. And then if you need it for testing, you could test with that, with the clone file system that would be mounted read-write. But your warm read-only file system will not change. Right? And you cannot change the path or rename the volume or do any of those onto the warm file system. So that's a good, solid protection there if you need your data retained for a given period of time. Just a quick example of an implementation here. You could have your regular prod library. As I said, libraries contain policies, tape volumes. In that replication would go to your DR environment for your day-to-day business requirements. And then you could have a warm library where you write your critical data, the data you want to make sure that you always keep, or in this case, your ransomware, if you want to do a daily backup of specific data for your ransomware, you could do that on a warm file system and it gets replicated to the DR, the data center, the DR, right? And that again is a copy that cannot be modified in any way, shape, or form, nor both at the prod and the DR. So the replicated worm file system is the same, has the same characteristics as the original one. It cannot be changed either. The fourth tool to help you with cyber shield or cyber security is the cloud support. We provide cloud support through the use of a cloud gateway. So on the VTN, in this example here, you have your system. It has a ransomware system local that you only direct write to. The best way to isolate your ransomware system is to make sure it has no network connections. So a dual write option is always the best in those cases. But let's say from your production perspective, you write down to your you write down to your local VTN with your ISN. Your data gets replicated between your DR and prod system, but you can also either directly write to a cloud gateway or replicate your data to a cloud gateway. So the replication would allow you in this case to set which policies, which range of tapes you want to replicate to the cloud gateway or to the cloud, and which ones you don't need to. And that can be done as soon as the tape is unloaded or on a nightly basis on a schedule if you want to replicate an entire policy or mount point file system. And that goes to the cloud storage, right? Cloud, most of you probably know, you can move the data around in your cloud. You can have buckets here and there. They can be accessible in different locations. So the big advantage of doing that for your third or fourth copy, because you have basically, you'd have one on your end somewhere, one local, one DR, and that would be your fourth copy. The cloud allows you to do versioning, so basically it keeps incremental of your changes on your files. So you could recall an earlier copy of a file if you needed to, or a file system. And there's ability to have immutable copies on the cloud as well, so you cannot be modified or destroyed. And then from the cloud, you also have tiering options, so you could move the data that you know it's not used to a lower tier to save on cost. And then if you ever need it, you can put it back up the chain in the tiers and get it back. You can actually restore from the cloud. We could, if the bucket is connected to the gateway, you could mount a tape that's on the cloud gateway and IPL your system from there if you need to. Right? For us, it's just another mount point, another location to get data from, so you could IPL from there if you needed to. And that is it for those bit more details on all the four Cyber Shield options. And then on this, I will turn it back over to you, Sean.
Perfect. Thanks, Serge. Appreciate that. So from here, I'd like to talk about how are these features put into the solution, and what are the combination of these features that our customers are leveraging. So we're going to look at that. We're going to look, before we look at a couple of those examples, I want to make a point that we've been hitting on because it's very important. The ZVT models all have two standard features that any customer of ours that utilizes a 5000 INAS can implement today. No additional cost. You can implement and turn on your data integrity checking. You can leverage the cloning capability on the intelligent storage node to set up that isolated directory of your file system copies. So those are standard features. You can do that on your INAS today if you're a user of INAS products. And that's kind of a rare thing. So I wanted to really just make sure that was clear. These are two standard features that all of our customers can be using and should be using, frankly, to protect themselves from some of the cyber threats that are prevalent today. Okay, now, this is kind of a good, better, best way to think about these sets of features. As I just said, on all INAS systems, you can immediately implement data integrity checking. For peace of mind, you can also implement a cloning structure that will help you implement right? You could set up for 30 days, 60 days, 90 days, 6 months, whatever you want in terms of your directory of clones. That's a standard feature set, and you can implement those 2 features today on your INS system, okay? You can also add worm to that. You can add a cloud connection, so you're writing another copy to the cloud, as Serge just detailed, right? So there's some basic features available to you as an INS user that you can implement today. We move to the middle or the better category. This is actually representative of a customer who's invested in a separate system, a ransomware ZVT system, but they're replicating from their production data center, or sorry, their production ZVT, I should say, right? We have a customer. In fact, I'm going to show you an example in a minute of a customer that's implemented this exact configuration. They have a lot of confidence in their network security. So they feel like they are covered by replicating from their production ZVT to the ransomware system. So they have that island created with the ransomware ZVT. The data moves over and is cloned. And again, as many days of clones as you want can be set up. And they rotate. So if you have it set up for 60 days, the oldest falls off as the newest comes in, right? It's not quite optimal because you still have IP connectivity into your ransomware system in this case. So you could have a lot of security on your network. You could even have a dedicated Ethernet cable sitting, these could be sitting right next to each other with a dedicated Ethernet connection, which would be the most secure way to do it. You can also add worm, of course, to this. You can add cloud connectivity to this. However, if you look to the far right, the absolute best way to do it is to create that air gap solution. By air gap, we mean no network connectivity whatsoever. Write the data directly to the ransomware system from the mainframe. That's the most secure way to do it. You eliminate IP risk there. If you need to manage, monitor, upgrade the microcode, you connect with a workstation or a laptop directly to that ransomware box to execute that task. So you're not connected to a network in any way. So that's your most secure approach. By the way, you can add this ransomware system to your environment regardless of what your virtual tape system is or brand that you're using. You might be using an IBM 7700 or any other virtual tape from a different vendor. You can implement an Optica ZVT 5000 INAS system for your ransomware protection because it's completely air-gapped and isolated. You're writing the data that you want to write directly to the ransomware system. So it doesn't actually have much to do with the rest of your virtual tape environment. If you need to restore, you do that back to the mainframe, so you can do it alongside any brand of virtual tape. So that kind of gives you a sense for how you can implement these features. Some are standard, some are licensed. The majority of them are standard. So there's multiple ways to do it, and every customer thinks a little bit differently about how they want to do it. So I want to show you 3 customer examples here, and then we'll leave some time for some questions. So the first example, this is a transportation company. This is the one I referenced. They have a dedicated ransomware ZVT system that they invested in, and they chose the INAS for that, of course, because it's the fully featured system. They actually chose the Flex model for their production virtual tape. They liked the feature set of the IBM Flash Storage 5200 system in this case, the fiber channel system. So they invested in the Flex model for production and their DR virtual tape. But they wanted the INAS system for their ransomware protection. So they actually do unique tape processing on both their prod ZVT and their DR ZVT, and therefore they replicate from both prod and DR into the ransomware system. Okay, so this is a little unique in a couple ways. They have mixed models, and they also replicate from both prod and DR ZVTs into the ransomware system. And all of their file systems are cloned, in this case, for 30 days. That's their choice. They wanted to do it for 30 days for each file system. So that includes their test data, their backup data, and their production data that they're cloning on the ransomware system. They are very confident in their network security, so they felt comfortable attaching the ransomware via replicated links. So they have very highly secure network in their environment. Okay. Example number 2 is quite similar. This customer standardized on the 5000 INAS for their production and their DR, as well as their ransomware system. The difference here is this customer is doing direct writes from the mainframe. So no IP connectivity on that ransomware system whatsoever. And so this is the optimal way. They are actually using cloning, they're using the warm feature, and of course data integrity checking. So they have a very secure ransomware system to help them protect against cyber threat and ransomware attacks. So this would represent that best category that I showed you previously. And then the third example is also quite similar, a little bit different in that their ransomware system is actually secured physically. It's in a cage. So they locally replicate to a ransomware system from their production ZVT, but there's only a couple of privileged individuals that have access to this secure environment where this particular customer has specific assets inside the cage, inside the locked cage. So this gives you physical protection of your ransomware system, which I guess if you really think about it is you're protecting against the rogue employee predominantly, or rogue vendor, right? Not that there's any rogue vendors, but this gives you that physical level of protection. So I thought that was an interesting example to show as well. Okay, so that's 3 different customers who have implemented the feature set in a little bit different combinations across a couple different models of ZVT. Okay, so just to show you the flexibility that you have. All right. All right, so I'm going to wrap up here with just a slide that kind of summarizes the advantages we've talked about, and then we'll get to some questions here. So there's a set of what we consider base technology advantages. We think this is the most modular, flexible, scalable, and resilient system available within the industry. We use high quality, reliable, extended life hardware. So we're not going to sell you a system and then in 1 year tell you it's end of life, you have to replace it. We offer an extended life platform for a reason. We give you a support runway that is beyond the typical vendor runway for support. So that gives you a very nice TCO and ROI. We think we have a very flexible, intuitive GUI. We give you the flexibility of controlling and managing and monitoring also from JCL or CLI. So anything you can do in the GUI, you can do via CLI and JCL as well. And then it's an easy product to implement and to use. And that includes migration, right? As we talked about with ZCC, a very powerful way that will get you from your existing environment to the ZVT. And then we have a set of advanced features. We talked about one-click DR. That can prep you in minutes versus hours to do your DR testing. We have probably the most complete set and list of modes for replication that you can choose from. We have that ZCC tool set that's going to get you migrated seamlessly from your existing system to the ZVT. You can do it via the host or you can do it hostlessly. In either case, ZCC will be the engine that migrates those tapes, that imports those tapes for you. Okay. And then the support for cloud and the migration to cloud is that we've detailed extensively here. And then finally, we have this commitment, right, that I've mentioned before to world-class support. We take great pride in that. We feel that if you talk to any one of our customers, we hope anyway that one of the first things they mention is that they appreciate the support they get from the Optica team. So we stand behind our solutions and stand behind and with our customers. We've made a huge investment in the mainframe lab we have at our headquarters. We also have a tight relationship with IBM. We just came from the Washington Systems Center a couple of weeks ago. We wanted to be certified and qualified on the new mainframe, the new FICON chipids. So we invest in that type of testing. We have an excellent relationship with IBM in order to do that. And I skipped over this one that's important. We're innovative, right? We listen to the customer. We often create features, develop features based on customer request. So we're nimble. We have a very nimble engineering organization and we respond to our customers. And then finally, that TCO that I mentioned, we feel is the highest in the industry with the ZBT system. And then, Cyber Shield feature set, the key to what you heard today, I think, is we have an affordable set of features. We have a flexible set of features that you can implement right out of the gate with no incremental cost to begin protecting yourself. And then you can scale that protection as deeply as you'd like with a air gap system, fully featured system to give you the optimal protection if you so choose. So hopefully that was helpful. Hopefully that was a good overview at the right level of detail to demonstrate the flexibility of the feature set and the investment value that you're going to get relative to cyber protection and virtual tape when you partner with Optica and the ZBT system. Okay, so thanks again. And that concludes the slides that we prepared, and it brings us to, I think we have a few minutes, Janine, for a few questions.
We do, Sean, and we actually have a lot of questions. So we may not get to them all, but do know that if we don't get to your questions today, someone will reach out to you via email to get you an answer. And Sean, too, if I might take just a moment, these charts are just jam-packed with great information. So a reminder, if you join late, you can download a PDF version of the slide deck. So check out event resources on the left side. Use that drop-down menu to download those slides before we end today. Okay, Sean, let's start with this one. First question, what planning and implementation requirements are needed to deploy the worm feature effectively? Is there a best practice?
Okay, so the worm feature, I'm going to ask Serge to answer that one. Serge, if you could take that. I know you've implemented dozens of these globally, so I'm going to let you take that one.
Yes. Okay, thank you, Sean. Yeah, we basically work with every customer to implement a solution to meet their requirements because everybody is different. As I was mentioning earlier in the feature, not all file systems might be warm. You might need, only certain ones. So basically, with that, when you create a warm file system, it has unique features and characteristics that will affect your day-to-day tape management operation and tape management system. For example, you can no longer expire tapes or scratch them since the file system is read-only and you cannot modify them. So that basically would you would have to think or architect your system where you know that you cannot scratch the tape until the last tape in that warm file system is basically expired, at which point what we would do is remove the old one, create a new one with the same tapes that all you would have to do is run the scratch on your tape management system, and then you would still be able to use the same tapes as you had before in your tape management system. But again, it's planning and slight changes in the way you operate your tape management system, knowing that these files never be modified, basically, until your retention period is expired, at which point, if the retention period is expired, you don't need them anymore. We just delete the file system, create a new one. And then you can reuse the same as far as the tape management system. If we add the same volumes, your tape management system will see the same volumes and just basically scratch them, and you can start over.
So we offer that consulting then with each customer who invests in worms. So we offer that consulting as part of the package.
Yes, correct.
All right, thank you. As mentioned, a lot of questions still to be answered. So look forward to getting a response to your questions via email, because that's all the time we have for today. So I want to thank everyone for attending today's webinar. I especially want to thank Sean and Serge for sharing their expertise with us today. Later this week, do watch for a follow-up email. It will contain a link to the recording of today's webinar. Get all the latest on all things tech by going to techchannel.com/subscribe. That concludes our webinar. Thanks again, and enjoy the rest of your day.